Welcome back, students. In this video, we're going to cover lesson 8.1, dilations. Excuse me. It's the first page of the Module 8 packet. Excuse me. Kind of reformatted the notes to make it flow a little smoother. All right, so a dilation is a non-rigid transformation that enlarges or reduces a geometric figure. So up until this point, we've been dealing with rigid transformations because the shape, whether it moved or reflected or rotated, the shape stayed the same. Where now, this is going to enlarge or reduce. So it's going to get bigger or smaller. And as I've been saying in class, when you go to the eye doctor, they give you those drops that make your eyes dilate. Your pupils, it makes them bigger so the doctor can run tests and stuff like that. Well, getting bigger is not the definition of dilate. Dilate's to enlarge or reduce. So that's why there's my little reference for the video. So when a figure is dilated, the sides of the image are proportional to the sides of the original figure. The angle measurements do not change. Okay, so like say if we have a square and we have a smaller square, well, these are 90-degree angles, so are these. The sides are in proportion. Let's see. We're going to be dealing mainly with triangles, but also circles would be the same thing. It has no angles, so, but the radius or the denominator, the radius or the diameter changes with the circle. Anyway, center of dilation, the center point from which the dilations are performed, most of the time it's going to be the origin, but sometimes it's not. Now, when it's the origin, so scale factor, it's also letter K. That's the ratio of the length of the image to the corresponding length of the pre-image. So, new, old. So K is new divided by old. So, let's see. And again, so when we're dealing with the origin, it's going to be coordinate rules is going to be x comma y. It's going to be kx comma ky. So you're just multiplying whatever that ratio is. So an enlargement, that's when it gets bigger. K is greater than 1. And a reduction, when it gets smaller, so it's not going to be a negative number, so it has to be greater than 0, but less than 1. So most of the time you're going to be talking about decimals or fractions, but to get smaller it'd be like 0.2 or 1/8. Over here, to get bigger it'd be like 4 or 12, that sort of thing. So let's look at their little example. To find K, divide the new over the old. So, like I said, new over old. Here they tell you, so the old is this guy, the new is this guy. So, new over old is going to be 22 divided by 55. 22 divided by 55, K is 4. So, 4 is bigger than 1, so obviously this is an enlargement. You can tell by looking that this is bigger than that. But the number was greater than 1. So mathematically and visually. All right, so let's look down here. Let's go to the bottom. I'm going to reposition my camera here. Okay. Let me just a little bit further. Okay, sorry about the bounce there. All right, 1 and 2 go with the left. 3 and 4 are going to go with the right. All right, so, and for the purpose of this video, I'm going to just go ahead and do both of these problems. I know we usually have the you do and I do. In this video, I'm going to go ahead and do Let's see. Yeah, I'll go ahead and do the problems for this one. All right. So, number one. Actually, the back is that. So, anyway, the only one I'd be skipping is this one. So, we'll go with it. Determine if the dilation from ABC to DEF is an enlargement or a reduction. Okay, so we're going from here, it's going to be your old, to, it's going to be your new. So old to new. Remember, K is going to be new over old. So for number one, they're asking, is it an enlargement or a reduction? So is this bigger than this? Or is this, who's bigger, who's smaller? Looks to me like this is bigger than that. I know I've told you guys don't make assumptions, but it's okay here. So this is a reduction, because we're going to do the math and prove it anyway. So number two says, find the scale factor of the dilation and then write the coordinate rule. Coordinate rule goes back to your x comma y. All right, so K is your new over old. So new is this side's 2, this side's 6. So 2 over 6, that reduces to 1/3. So our scale factor is 1/3, which is less than 1. So reduction was correct. And then what's the coordinate rule? So x comma y, in this case, it's kx, or 1/3 x comma ky, 1/3 y. All right, hopefully that makes sense to you. All right, right side of the page, number 3 and 4 go with these two guys. All right, so determine whether the dilation from ADC, so the little one, to PQR, so we got bigger. So number 3, is it an enlargement or a reduction? Well, if it got bigger, it's an enlargement. So that means when we do number 4, it's going to ask for the scale factor. K is new over old. So this is the new, this is the old. 6 over 4, which reduces to 3/2. So remember, even though this is a fraction, 3/2 is an improper fraction. It's bigger than 1. So this is 1.5 or 3/2. So coordinate rule, x comma y. And in this case, so instead of 3/2, I'm going to write 1.5 x comma 1.y. So 3/2, 1.5, same thing. I would not mark you wrong here. All right, let's flip over. It's been a while since we've had a video. So just zoom out a little bit. So that's going to be our okay, for those of you that actually do listen, the bonus word for this video is going to be well, it's not going to be a word, but it's been a while, or just say been a while. If you put that in your notes or send me a message in Teams or Focus, just been a while, then I'll give you the extra credit for video for lesson 8.1. Okay, let's get up here. So, top of the page. TRS has vertices, and they give us those coordinates. -4, 5, 0, 6, and 4, 3. Find the coordinates of the vertices and graph TRS and T prime, R prime, S prime. So this is your old, this is your new, after the dilation. All right, centered at the origin. So the coordinate rules I gave you guys are in play right now. That's not going to change until the next problem. The next problem, we're going to, once I move my hand, excuse me. Sorry, okay. The problem below, it doesn't go from the origin, it goes from a point, but we'll get to that in just a minute. All right, I make my own origin. This is, you see it doesn't have one. Graph paper, same thing. Somebody asked me, how do you determine? Well, just kind of look for the middle. It doesn't have to be perfect, but excuse me, labeling your origin keeps you honest, and if you're doing more than one shape, you can't miss where the origin is and accidentally write something wrong. Say, how do I know that? Well, you know, because I've done it. So so for our coordinate rules here, k is a half, so x comma y is going to be 1/2 x comma 1/2 y. All right, so down here, I'm going to go ahead and do my math, and then we will graph our figures. So t starts out at -4, comma, -5. R is at 0, comma 6, and S is at 4, comma 3. All right, so all we're doing here, I keep thinking this is the third step, but that's down below. So all we're doing here is we're multiplying each of these numbers, and I'm going to try to do it slowly here. So we see all the math. I told you guys in class that I would take it further during the video, which I usually try to do anyway. Okay, so we're going from here. It's going to be kx, so kx, ky. All right, so 1/2 times -4, or half of -4 is -2. Half of -5 is -2.5. And this is, of course, t prime. All right, so we're going to do the same thing here. All right, 1/2 times 0, because that's your x, comma 1/2 times 6, because that's your y. Hang on 1 second. Sorry, you guys. Multitasking. Sorry about that. Let me just, oops. All right, so anything times 0 is 0. This is r prime. And then 1/2 of 6 is 3. Down here, 4, 1/2, and then 4. 1/2, and then 3. Gives us s prime. Didn't forget to write it for once. 1/2 of 4 is 2. And 1/2 of 3 is 3/2, or 1.5. Okay, now let's plot our points. This could get interesting because I seem to be short of markers at home. Apparently Santa didn't bring me new colored pencils, but that's okay. I have them everywhere, just not in front of me at the moment. Okay, so let's start out with our original. So -1, 2, 3, 4, and then -1, 2, 3, 4, 5. So I know this thing gets smaller, so I can write here. So there's t. All right, 0 and then 6. 1, 2, 3, 4, 5, 6. This is r. Let's see if this will help my little lighting. I need a producer and a director or something. Let's see if made it worse, made it better, made it worse, made it worse. I don't know. All right, so 0, 6, and then 4, 3 was our s. So 1, 2, 3, 4, 1, 2, 3. Sorry. Easier to watch the screen when I do this, but sometimes my eyes and everything not working together. Hang on, guys. Where'd T go? There it is. I'm having to use an envelope because I'm just an old, sad person here. Envelope's not a great straight edge. Every adult possibly run across this as like, well, yeah, idiot, use an envelope as a straight edge. Okay. All right, there we go. So, forgot to write S. So there's your original. Let me see. All right. So new points are -2, -2.5, 1, 2.5, 0, 3, so 0, 1, 2, 3, and then 2, 1.5, so 1, 2, and then 1, and right in the middle there. So we went from the big triangle to the small triangle. And that's half the size. For those of y'all that are doing the math, and I hope you are. All right, number 5. So 5 and 6 go with this guy. Notice E is our point of dilation. So things are just a little different. I'm going to have to make space for this to fit. So I'm going to pause just a second so I can plot our point. It'll be quicker. Stand by. Okay. So I went ahead and plotted our points. Probably could have written them out. That's okay. We're going to do it this way. A couple of things. So let's put this, yeah, we'll go right here. E. So our point E is at 9, 3, because that's important. So for our coordinate rule, so the number 6, we're going to put the answer over here. I'm borrowing this space over here for our coordinate rule. So x comma y, it's not as simple as kx, ky, because we're not dilating from the origin, we're dilating from a point. So that formula is, so we go k times x minus, and so our point here, it's a, so the x up here is 9, that would be -9 parentheses, and then outside the parentheses plus 9, or in this case a, for the formula. And then over here, k times y minus b, or the y coordinate, 3, close parentheses, plus b. So you'll see up here as I write it out. I'm going to try to do this. So 3, 3, our k. So we're going from D, E, F to D prime, E prime, F prime. So obviously it gets smaller. So let's count how big it was. We go from D to E. DE was 1, 2, 3, 4, 5, 6. Let me just do this. 1, 2, 3, 4, 5, 6. So just kind of write the, I'm going to write this. Running out of space. So DE was 6. So D prime, E prime, let's see what it is. This is your new, I'm sorry, your old. This is your new. Remember, your K is new over old. All right, so D prime to E prime is 1, 2. So our K is going to come over here. K is old over new, 2 over 6, which reduces to 1/3. And it better be less than 1 because this guy got smaller. So over here, K is 1/3. X, that's 3. Minus A, which is 9. That's from that point, okay? plus 9. And then it's again 1/3. Y is 3. So, and this is 3. This y coordinate here. So it's 3 minus 3 plus 3. All right, so D prime. Let me see if I can get going a little bit here. So 3 minus 9 is -6. Okay. All right, -6 times 1/3, or -6 divided by 3, gives you -2. -2 plus 9 is one side. All right, this other side, 3 minus 3 is 0. 0 times anything is 0. Plus 3. So we go over here. I'm not writing D prime again. You guys should know. So -2 plus 9 is +7. And 0 plus 3 is 3. You see here, D prime is 7, 3. So we're right. Thumbs up, but you can't see me. So let's go over here. F. Now, our F prime is 8, 5. So let's see if we get there. All right, so we're 1/3 times the parentheses X. This is 6 minus the A, which is 9, plus 9. I didn't mean to do that. Ugh. It's okay. Comma 1/3. Y is 9. The B is 3 minus 3 plus 3. So we'll scoot this over and we'll say, I'll do this under here. So 6 minus 9 is -3. 9 minus 3 is +6. All right, so 1/3 of -3 is -1. Well, yeah, so -1 plus 9. And then the other side, so +6 divided by 3 is 2. Plus 3. Oops, plus 3. All right, so -1 and a +9 make a +8. 2 plus 3 makes 5. That's F prime, which is 8, 5. So check and mate. Can't give you a thumbs up, so we'll just give you the upside down star because, you know, I'm upside down on this. Number 6. Our angle measure and or distance preserved in D prime, E prime, F prime. So is it the same angles? Well, yes. So angles are preserved. But the sides, you see it went from 6 to 2. So sides are not. Okay? All right. Video's getting long, so let's get down here at the bottom. We're going to scooch out. Hopefully you guys weren't paying attention. If you were listening earlier, you know that's the word. And if you weren't listening and caught that, well, there's your chance. I throw those bonus words in for those who listen. All right, number 7. Graph the image. So remember, the pre-image is where we start. After a dilation centered at the origin, so normal rules, x comma y, be kx comma ky. K is the new over the old, just kind of throwing some info out there. But they want to dilate this guy by a scale factor of 2, so that's bigger than 1, so this guy's going to be bigger. It's going to get bigger, and then they want to translate along vector 2, 2. +2 means this is left to right, so this is going to the right. This is your up and down. Negative means down, so right 2, down 2. So a two-step movement. This is a level 5 question on the EOC, so I'm just going to quickly, I have all the coordinates. Normally I like to do it with you, but I hope at this point you know how to graph. If you do not, then please go back to earlier videos. I believe it's module 3, possibly module 4. There's a lot of graph, and I go through, your X is left to right, your Y is up and down. So anyway, the first thing you need is these 3 points. We're doing those. So it's going to go, I'm going to write our coordinate rules down here. Well, it's x comma y is kx comma ky, and then your next, it's going to be, so it does this is your, and then your next thing is going to be, messing up all my room, dang it, x comma y is going to be x plus 2, y minus 2. And that's because of this guy. All right. So, here, so negative 3 times 2. So let's just do this. Comma. Yeah, 2 times 4. Yeah, we're going to run out of space. That's okay. We'll take it down here. We'll just do this. So 2 times negative 3 is negative 6. 2 times 4 is 8. So we'll take that down here. 6, 8. And then it's 6 plus 2, 8 minus 2, which is, so makes our A prime prime. 6 plus 2 is 8. 8 minus 2 is 6. I did this right. Where did I get? Hang on. Plus 2, yeah. Negative. Yeah, that was negative 6. Wait a minute. I got 6, 8 here. How did it be negative 6? Alright, then it's plus 2. So negative 6 plus 2. Yeah, that's negative 4. I wondered why my numbers were not looking right. So I wrote my numbers down wrong from here to here. So negative 6, 8. Negative 6, 8. Negative 6 plus 2, 8 minus 2. So negative 6 plus 2 is negative 4. 8 minus 2 is 6. Alright, so 2 next. 2 times 2, comma, 2 times 2. Well, that's 4, comma 4. So we'll say, go over here, 4, comma 4. 4 plus 2, 4 minus 2. So B prime prime. 4 plus 2 is 6. 4 minus 2 is 2. Sure you guys can see all that. All right, lastly, C. Negative 2 and 2. I wrote that backwards, but that's okay. We're still going to get the same math. The symmetric property. All right, so negative 2 times 2 is negative 4. I won't have to go down there with this. Negative 4 times 2 is negative 8. Well, maybe I will. Negative 4 plus 2, negative 8 minus 2. So going down here, C prime prime. So negative 4 plus 2 is negative 2. Negative 8 minus 2 is negative 10. So here's our 3 points. So let me graph this very quickly. We'll say, all right, so it was negative 6. And so see, these are 2, 4, 6. So your odd numbers are in between. So negative 6, positive 8, positive 4, and where are we at up here? Negative 4, negative 8. perfect. I forgot my straight edge. Okay, so you see it blew up. It's twice as big. All right, we have the coordinates, but we also know, so this is left to right, this is up and down. Positive is right, negative is down. So we're going to the right 2, down 2. So you go to the right 2, down 2. To the right 2, down 2. To the right 2, and down 2. So let's check our points. So -4, 6 is right here. +6, 2 is here. And then -2, -10 is down here. So it wore, goodness, there went the rest of that pencil. Well, shoot. Oh well, so let's, I went way off there. Sorry, ignoring my bad drawing, so it scooted over. All right, and bottom right here, last little thing. Are the angle measurements and or distance preserved after a series of transformations? Well, so this series, the angles are preserved because they are with anything we do. The sides were not. And it's because we may have scooted over, but we got bigger first. All right, so hopefully that gets us squared away with 8-1. If you have any questions, please let me know. Until next time, have a good night.